Hello everyone, and thank you for attending today's webinar, Industry 4.0, How to Move Beyond POC and into Production, sponsored by Cloudera, Telit, and IBM. My name is David Green, and I'm the Consulting Director for AI and IoT at Omdia. And good morning or afternoon to everyone, depending where you are. Thank you for joining the session. I'm delighted to say I've got three great speakers and panelists today. They are Jose Favilla, who is Worldwide Director and Partner, Global Industry 4.0 Leader, Industrial Platforms at IBM. We have Ricardo Veronello, who is Head of Platforms Business Unit at Telit. And we have Mike Gare, who is Managing Director of Manufacturing and Automotive Industries at Cloudera. And I'll give each of those guys a proper introduction just before we hear from them in a few moments. First, just to show you what we'll be talking through today, we have released a new industry survey looking at Industry 4.0, and I'll just briefly mention what that is and kind of set things up so you understand the background of where we're pulling some of the insights from today. Then we'll bring the panel on board. We'll get them to give themselves a proper introduction. And then we have kind of walk through the highlights and the key parts of the survey. So the idea of building a foundation first, the risk of cloud versus the reward of cloud versus the cybersecurity risk, some of the challenges, both on the human and the data side, and then a little walk through some of the future applications just after that. To start with, let's talk about the survey. So our new end user survey, every industry is going through some form of digital transformation. They may call it different things. It might have slightly different shape in different places. Industry 4.0 is the name within manufacturing, but every industry is going through that same kind of fundamental shift. But of course, every industry has its own nuance. And together with the partners for this survey, we wanted to really dive into what the drivers, what the status, what the challenges and the applications were for the manufacturing and related industries. So in September, we ran an end user survey, global in scope, and 53 respondents, but only from those kind of industries to really get under the hood and understand what's going right and what's going wrong within that industry. To give you the first kind of insight and an insight into where people are, one of the first questions we asked was, what best describes your current status with Industry 4.0 adoption? And you can see, 17% still just at the investigating stage. But if you aggregate, there's a couple of interesting things there. So we have 36% of the industry say they're already into some form of full production, whether that's on a single application or multiple applications. 36%, so just over a third. Actually, 43% are somewhere in the POC stage. So that's either developing the pilot or already running the pilot and evaluating. 43% is pretty high. What's also interesting, and is one of the other survey questions we asked, was what proportion of POCs do you think make it to full production? And again, the answer there was actually 43%. So lots of people are in that POC stage. Still over half fail at that stage. Is that a higher or lower number than you maybe expect? Is kind of something to explore. But it shows you that people are investigating and that the number going into full production is only increasing despite some of the challenges. To dive into what some of those challenges are, like I said, we're going to draw on the experience of our fantastic panelists. And also we have from our panelists the ability to tell us what is Industry 4.0 mean to you and to your business. So in order, if I come to you, Jose, and you give yourself a quick introduction, and what does Industry 4.0 mean to you and your business?
Sure. Thank you, David. If you can please go to the next slide. Again, my name is Jose Favilla. I lead globally for IBM Industry 4.0. As you can see here on the screen, on the left side is a very broad topic, of course. As you may know, Industry 4.0, the term was coined in Germany back in 2011. In other words, we are now the 10th year anniversary of Industry 4.0. A lot of promises, of course, digital factories, digital twins, the integration horizontal and vertical across the value chain, the flexible manufacturing, the connected product doesn't stop in the factory, of course, goes all the way into the field, connecting the products, provide service around the products, better customer experience there. The convergence between the IT side of the house with the OT we mean operation technologies. Cybersecurity, of course, becomes a hot topic. Sustainability is coming up in a very strong way now, as well as the shareholder, the value to the shareholder, the worker, in the society. The last two topics here are in yellow because they are now being referred as Industry 5.0 as well. I prefer to stay with the topic Industry 4.0 and just add these two other elements to the story there, right? So very broad topic, a lot of promises there, right? A lot of cool stuff, very cool POCs, but I think the whole goal of the industry now is to really to scale how we can drive these to the several plants, to the whole processes, and really capitalize on the value that you can drive around Industry 4.0. From our perspective, we see three main processes there. One is designing the new products that we call engineering lifecycle management. The idea here is that the products themselves are becoming much more software defined, right? And it's not only about designing the products, but updating the products in the field and provide additional, much more, services around it as well as a superior customer experience. The whole engineer life cycle becomes very hot topic there. The second one, now that you have your product, design your, getting your parts, as well as the manufacturing the products in a factory, of course, and deliver these to the field. And the product can be a major industrial machinery in the field, like a Caterpillar truck, or could be a major turbine in a plant, or could be a product in our hands as a consumer there. So the asset life cycle management part of the product is becoming a very, very important topic. Just to summarize, in fact, scaling Industry 4.0, a few weeks back, I recorded a podcast that if you want to spend 1 hour talking about scalability pretty much on this topic there as well. Would be good. And of course, value is everything behind it. And the value, we work together with Forrester Research on their Total Economic Impact series, where they interviewed a number of IBM clients and they look at the value. What was the value realized by implementing these capabilities in their clients? Highly recommend you to read this report if you have opportunity. It's a 30-page report that goes really deep into the value side. With that, turning on back to David.
Thank you, Jose. And Mike, over to you.
Thank you. And thanks for the introduction. Guys, my name is Mike Gar. Again, I'm the Managing Director for Manufacturing and Automotive here at Cloudera. At Cloudera, we are a data management platform. So I want you to kind of think about, we look at Industry 4.0 through the lens of the data management lifecycle. As we know, equipment's getting smarter, processes are getting smarter and more automated, right? But those smarts are very often in Industry 4.0, the result of a machine learning lifecycle, right? And it's a data management lifecycle at its core. And just to kind of walk you through how we see the world, right? The data management lifecycle looks kind of like this. So if you look at the top of the slide and you see those connected plants, right? You've got OT data in those plants, IT data in those plants. You've got increasingly image and audio type of data. The challenge really becomes, in terms of using this data for a machine learning lifecycle, is to be able to collect that data. And you see that in number one, right? And you want to, as you're collecting it, in number two, you can see that you want to be able to look at that data. You want to be able to analyze it in stream, perhaps. You want to be able to take real-time streaming analytics actions, which you see on the right side. But as I'm going to show you, this ability to take real-time actions is actually the result of a machine learning lifecycle. And what do we mean by that, right? So once we've collected that data, as you can see, when you go down to number three, we want to bring that data either into a data center, and that data center could be your corporate data center, it might be within the plant, or a data lake, whether it be on-premise or in the cloud or on multiple cloud. Our platform works on all of those different things. But look, you want to be able to collect that data. You want to be able to store it. You see in number four, you want to take that, oftentimes that sensor data that you got from the plant and enrich it with data from, in number five, your enterprise data. So now you're pulling together sensor data from the edge with your enterprise data. You now have all the data sets you need to start to do much better analytics, which you see on the right. In number seven, right, you can put a query layer over it and do self-service BI, for example, right? But the real opportunity is if you see in number 8 there, right? You've got now histories of data. So for example, if you're doing predictive maintenance, you have sensor data on the one hand from the edge, and then from the enterprise side, you had your asset management system, right? Your maintenance management system. So now you can see which sensor values correlated to the need for maintenance, right? You bring those data sets together, create machine learning models, and then you can see in number 9, you deploy those models back out to the edge, which is how you took those intelligent real-time actions in number 2. As you're sniffing that data as it's coming in, you're leveraging that model to take intelligent real-time actions. So you can say, look, we see the conditions of certain equipment. Let's schedule maintenance for the future. Let's order the supply, order the part from our supplier. All of this before the component fails. So again, we see this machine learning, this data management lifecycle as being critical to to Industry 4.0, and that's really where we're playing as Cloudera.
Thanks, Mike, and a nice overview of the kind of system in action. And Ricardo, same question to you to introduce the Telit perspective.
Hello, guys. Really nice to be here, sharing the stage with all of you. My name is Ricardo Brunello, and I'm Senior Vice President and Head of Telit IoT Platforms. Telit's a global company, and our software division started more than 30 years ago, basically inside IBM, as a product called IBM PlantWorks. And we kept investing on this product during the last 30 years to the point that we are today. In the year 2013, Telit acquired this spin-off of IBM Automation Group, a company called ILS Technology, and then we bring DeviceWise to the point that is today, and is recognized as a leader in smart manufacturing platforms. The way that Telit decided to approach this industry is by bringing a commonality in terms of these different types of IoT projects and digital transformation projects for the industrial landscape. I typically like to divide the industrial use cases in two big groups. One that I call connected factories, and then think in terms of end users, companies like Ford, like Coca-Cola, like Johnson & Johnson, and machine builders, companies that are producing machines and selling these machines to hundreds of customers. The way that this technology can revolutionize this space is by applying a common layer, and Telit DeviceWise is this common layer, a foundational block for you to collect data from any device with hundreds of native drivers. Translate this data on the edge in real time and integrate with any type of IT system, such as an MES, an ERP, asset management systems, databases, and more. DeviceWise also can provide a complete integration between these machines and cloud solutions, as well as a full SCADA and HMI system. So all this digital transformation now that in the past used to take months, if not years of development, now can be done in a complete no-code platform. So you can integrate on completely bidirectionally any type of machine and any type of IT systems. And with the advent of cloud computing and cellular connectivity, and even with 5G, this is even enhanced, is the ability of having this native software, edge software, loaded on cellular gateways like 4G and 5G gateways inside the cabinets of these machines, providing all the ability for machine builders to completely change the way that they have business. Now, if I am a packaging company machine, instead of selling machines, I might sell package as a service by remotely monitoring my machines that are with my customers' facilities, predict when these machines are about to fail, increase the uptime and the OEE of these machines, provide real-time data visualization of the full process and the efficiency of this machine, and even using inside DeviceWise a secure remote access for machine builders to monitor and actuate on these machines, fixing problems completely remote. So that is, the big picture of our vision, providing a unique platform that can make all the different components from hardware to software with all the different vendors and different protocols better with this completely integrated scenario.
Thank you, Ricardo, and indeed all of our panelists. I know that we have some really great case studies coming up later to see some of this in action as well. So look forward to seeing that. So let's dive into the detail. Let's start with the kind of building foundation of Industry 4.0. And one of the first questions that we asked in the survey was, which digital technologies relating to Industry 4.0 are you currently using today? And maybe predictably, but also kind of interesting, that the top 4 answers that really shone in this are what we would think of as the foundational layer, right? So that's cloud technologies, that's cybersecurity, that's IoT, and that's AI. A lot more of the other, maybe more specific applications, a little bit behind on that adoption curve. But that's maybe what you'd expect, and actually that might be best practice, right? Putting some of the foundational steps, particularly cybersecurity in the cloud, and we'll talk a little bit more about those two in a specific way in a moment. But Ricardo, so coming back to you, first of all, how does that resonate with what you see from the industry, and how do you go about talking about building the foundation of which the rest of the applications can then be built on?
David, thank you so much for the question. I think the most intriguing thing for me when I see this chart is looking at all these different technologies. And the conclusion that I take by reading it is more important than what is the first technology that is there and what is the second one, is that for any digital transformation, the coexistence of these technologies will be a must. So I took a couple of notes there saying cloud, cyber, IoT, AI, computer vision, machine learning, robotics, edge. If you want to be competitive in terms of your digital transformation, if you want to see your productivity to increase, what you need to do is you need to have a technology that will make all these different components to work better together. And that is the biggest challenge that you have in the industrial environment. When you go for the big automation companies like Siemens, like Rockwell, like Mitsubishi, these companies, they basically develop their products to be great with the other products that they have in their line, but not necessarily thinking in terms of how these POCs, these robots, these CNCs, will interface with the other CNCs from other vendors, with the ERP from SAP, with IBM Maximo, with different databases, relational and non-relational databases, with all the different cloud providers. And that is one of the biggest challenges that we see in this industry. So these different industrial protocols, they bring a significant restriction in terms of how the companies, they can evolve. And McKinsey brings a point that they say, listen, depending to the point of maturity that the companies are, they can gain from 5 to 40% of cost reduction with the adoption of IoT. So the vision that we have is the IoT is going to be the glue that will put these parts together. So making all these different machines, commonizing the protocol, the interface with them, integrating this in a completely bidirectional way with a layer of intelligence that you can program your system in a no-code environment, integrating all these different hardwares and all these different systems. Currently, Telit device-wise is used by 7 out of the 10 largest car makers in the world, by 10 out of the 20 largest tier 1 automotive companies. And what we see in this space is the very first challenge that they have in terms of having an efficient data analytics process there, to have a good preventive and predictive maintenance, good OEE and traceability and KPIs on their factories, is you need to make sure that you have an efficient data collection system, and you can commonize this data collection and add this edge logic intelligence there, so you can implement these foundational blocks before starting your other applications.
Absolutely, and I know that interoperability is a particular theme that comes up in challenges later on as well. So, and Joe, so from your point of view, and I think you have an end user example, particularly around the cloud and IoT part of that, of the kind of foundation layer.
Certainly. If you don't mind, you go to the next slide. So I want to talk about, how we are leveraging at IBM on what we're calling hybrid cloud, right? The cloud technology is there, right? I think we all know the importance of this. It enables different business models, etc. But from IBM perspective, we are looking more what we're calling a hybrid cloud. What would we mean by a hybrid cloud? Is First of all, is being able to deploy your workload in any cloud infrastructure. Could be IBM, could be Microsoft, AWS, etc. So make this cloud agnostic. That's one angle. The second one is about run is on a bare metal in a factory floor, or running on a private cloud, or running a public cloud as well. In other words, being able to redefine your applications and make it available in any environment where the end client wants. And that's pretty much the work we did together with Siemens. I believe Siemens needs no introduction. They are a major player in manufacturing space. One of their platforms is called MindSphere, right? This is their industrial IoT platform, and that's exactly the work we did with Siemens, replatforming, modernizing their platform to make this platform hybrid cloud enabled. Using IBM technology there. So that's the goal. And in fact, one broader topic we are seeing by work with many clients, as well as technology providers, is that there we see two major trends around this whole cloud. One is around, we call cloud out. It's more typically the hyperscalers, like Microsoft, for example, or AWS, expanding their cloud technology to the operation, to the edge, to industrial edge, as well as working with the other players, the automation vendors like Siemens, ABB, etc. That's pretty much are calling edge in. In other words, expanding their applications they have today already on the edge and going to the cloud, bringing cloud technology to modernize their infrastructure. Right. So this is the case for Siemens. And of course, one of the key overall inhibitors that to allow our clients to drive their whole Industry 4.0 project scale is the legacy they have. So a lot of work we are doing as well, work with many clients, in modernizing their existing legacy, containerize them, make it then, also cloud agnostic, run on a bare metal, or run any other platform for the end clients. This is, in our view, one of the key components to drive the scalability around Industry 4.0.
Thank you, and yeah, makes sense. And kind of on that theme, it draws us nicely to one of the biggest conclusions that came out of the survey itself, which was the reward of moving towards the cloud, but versus that cybersecurity risk, or at least perceived risk within the manufacturing industry. So we know that the manufacturing industry is very cautious, I would say, when chatting to the rest of the kind of fellow Omdia analysts around the team. We know that they have long hardware cycles, for example, and particularly anything that threatens the line going down, for example, on production, has huge cost implications. So there is always that huge kind of caution to move to something new, including the cloud. And I think what is interesting, and again, we see the cybersecurity angle come up multiple times as a perceived threat, at least within the industry. So here we have a question which says, again, which Industry 4.0 initiatives has your company initiated? And you see cybersecurity is up there as the number one in terms of already deployed. 70% of either already deployed or are implementing within the next 12 months, compared to some of these more practical day-to-day applications that are then layered on top, for example, manufacturing operations, which will come kind of later on. So again, this is cybersecurity as that foundational layer, but in particular, cybersecurity as then allowing you to move to the cloud and get some of the benefits that Jose just talked about. So again, we have a question which says, which best describes your cloud strategy for manufacturing? And hybrid cloud is up here as the single biggest answer. So almost a third, 32% of all respondents say they're already using some kind of hybrid cloud arrangement. And then after that, you have a mix. So you have some on private cloud, around 23%, and the same amount on a purely public cloud. What this screams to me is that you need flexibility. You need different options for different clients. Of course, one size doesn't fit all, but also that critical element that you have to have cybersecurity in place. And again, Jose, I think you have a customer example where it really shows that you need that cybersecurity layer in place for critical national infrastructure, for example.
Yes, if you can just go maybe to the next slide, just wanted to cover one of the cases. Of course, IBM is one of the leaders, of course, in the overall cybersecurity space. We have done a lot of work, of course, around the enterprise side, the IT side of the house. But of course, as we go into this industry 4.0, the operations becomes the next target, right? So we call this OT security. For the OT security is much beyond protecting data. We are talking about protecting, people, of course, protecting the assets, the environment. So it's a much broader topic. So we have been working with several partners. One of the partners here is around OT security is a company that I believe well known called ABB, right? And together with ABB, we have deployed a capability that combines IBM strengths and ABB strengths to go from the top floor all the way down to the physical machines in the bottom, in the automation equipments, etc. So in the case that we want to share here is about this company is the EWE Gas Special, right? This is a company based in Germany. These are one of the leading companies in the energy utility market. And in their case, they have several equipments that needs to be protected because they can, if we have a hacker taking control of those equipments, can become a major impact to the environment, for example, right? So we work together with ABB. ABB has all the instrumentation in this factory. And we work with them to combine one of our capabilities with IBM, QRadar, together with the ABB Event Collector and Forward to provide a top-to-bottom security for this client there. Again, very hot topic. We are doing a lot of work with other clients and other partners as well on the topic about extending cybersecurity to the operations environment.
Makes sense. And Mike, I think you have a kind of example that follows on from that, but cybersecurity from a wider perspective as well.
Yeah, exactly, Dave. If we just go to the next slide. Yeah, on this company, we're talking about, Mark, we're talking about not just cybersecurity, we're talking about broader security and governance, right, of data, right? Merck is a pharmaceutical company, highly regulated, lots of regulations around data security and governance in terms of who can see the data, right, and making sure that privacy is maintained. So this is a great example of a company that says, look, they actually had already implemented a data lake previously for small pilot projects and things like that. And they said, look, as we go forward, all this data is great, but it can get out of control, particularly in this highly regulated industry, right? So what they said that they needed to do is create a standard operating procedure for their data pipelines, right? So they needed to set up the zones where the data came in, right? Where it was secured, there was role-based security on who could see the data. There had to be specialized processes, how that data was massaged and cleaned, but most importantly, you had to track exactly who saw the data, how that data was changed, where the data was actually being used. So you have to track lineage and all those types of things. So when we talk about security, I think we need to extend to thinking about data security and governance, right? Because as you move out of pilot stage, as you move towards making this data available to the enterprise, with that comes a lot of responsibility, right? And I think this use case with Merck really illustrates that well.
I guess with big data comes big responsibility is what we're saying, right?
That's right.
So we'll talk about the data problem a little bit more in a few moments as well, because it comes up later in the survey. But we talked about a little bit about some of the technical challenges in cloud, for example, and cybersecurity. But one of the other big factors is, of course, the human challenge. And again, this really came through when we asked the respondents around their overall top challenges. So, yeah, what are your biggest challenges to implementing your Industry 4.0 initiatives? And I was really struck by the mix between those which are, I would say, technical and those which are non-technical, which are typically human or financial, or a combination. You can see over on the right-hand side, the single biggest answer was interoperability. And I said interoperability came up again during one of the slides earlier. I think, Ricardo, you were talking about interoperability challenge. It comes up again here as the single biggest challenge at 53% of respondents selected that in their top 3. However, the next 2 really are interesting. So insufficient senior executive support. And number 3 is insufficient employee skills and knowledge. And both of those are human challenges, right? One is about having the right skills within the business and the kind of combating the brain drain a little bit that we've heard about this year. But the other is the human challenges on aligning the different elements of the business. So it's, businesses are large and complex and sometimes aren't able to communicate with each other effectively. And that is a huge roadblock to some of these Industry 4.0 initiatives as well. So, yeah, I found it really interesting that 2 out of the top 3 were both that human challenge rather than necessarily being something technical or financial holding things back. Ricardo, from your perspective, from Telit's perspective, how do you see that with the customers that you're working on? And is there anything you can share as an insight from that?
David, I think that this question is probably one of the most insightful ones that you have on this research. Let me start with a quick comment on these results. Starting with the second most voted one there, that is insufficient senior executive support. I think this goes through a mindset transformation, that is the pursuit of the excellence and productivity. One of the impacts of COVID was many factories, they are now bringing their manufacturing close to their production markets. They understand that different geopolitical situations can impose significant threats for their supply chain. And if they want to survive, they need to use technology to increase their productivity. Paul Krugman has a very interesting statement that he says that productivity isn't everything, but in the long run, it is almost everything. So this mindset transformation on the leadership will be the most important factor for companies really to deploy this technology successfully. And most important thing that is transforming, the technology in ROI, in return on investment. And then I highlight 3 other topics that your research brings to us, that is the interoperability, the employee skills and know-how, and the ability of doing data collection. This human challenge also comes in the form of the lack of labor force and specific skill sets for you to deploy these. And if you can go to the next slide, David, please. In this use case that we have with American Axle, AAM, one of the largest tier 1 automotive companies in the world, I think that we really approached this. American Axle has more than, I think, 80 factories spread all around the world. Some of them were originally American Axle factories. Several of them came through acquisition. Interoperability and data collection is very challenging on the industrial space because of the different protocols that the machines have. Each machine was developed in a certain time to speak only that specific protocol. And even efforts of bringing open protocol like OPC UA and OPCDA also becomes very limiting depending on the type of integration that you need to have. So having this interoperability and this protocol translation might be very challenging. With this project, we connected more than 6,000 machines from all the different vendors, from Siemens POCs to all the different types of CNCs and robots. The first thing that we did was, by deploying DeviceWise, we created a completely transparent layer of communication, and we standardized all the machine communication there. And there are many benefits of that. The first one is, of course, making sure that you collect the data from all the different devices, from barcode readers to robots, from CNCs to PLCs, in one unique way. And you also bridge the gap of human resources that you have, because now instead of having hundreds of software engineers that will custom code and create protocol translation, now I can train them in one single platform, and then they can operate all these different machines without having the need or having the several experts on the several hardware platforms that they have. And with this came also the necessity of having the traceability, calculating the OE and other KPIs of productivity, where all this information was fully calculated on the edge, on device-wise, integrating with the different IT systems that the company has, from market solutions such as the AWS Cloud and IBM Maximo that they use there, as well as homegrown MES systems there. This full integration done in a platform, limiting the amount of custom code basically to zero, doing this complete IT and OT integration, and all the standardization in terms of these different devices. Not only we could integrate to these more modern machines that we can collect the data through native drivers, but we also could integrate legacy machines like CNCs that were built 20, 30 years ago, and there's nothing for you to collect other than the IOs there, where we could add hardware adapters, a product called the Smart IO, the Telit device-wise Smart IO, that we can translate digital and electrical signals, digital and analog IOs inside device-wise, having a complete integration from the most modern machine to the oldest legacy machine that they have on the shop floor.
Thank you. And it's interesting, you mentioned productivity there. I don't think we have the slide in this deck, but again, one of the first questions we asked in the survey was around what are the goals of Industry 4.0 for manufacturing companies. And yeah, increased productivity is number one goal. Kind of makes sense within the industry that they focus on the efficiency, the ratio of cost to profit, as it were. But so yeah, focusing on that productivity really makes sense. And by the way, it's probably a good time to mention that within the details of this webinar, you should be able to find the link to that report, so you can go take a look at some of the additional points that we don't have within the presentation today. As for the other challenge that we were going to spend some time on is around the data itself. So we've talked about the human challenge. What about the actual data itself? And again, there's a couple of questions that really point to this. So first was asking, again, maybe predictably, how much do people feel that data quality and the difficulties in collecting and blending analysis is maybe holding things back? So we can see 89% either strongly agree or agree with the statement that data quality negatively impacts successful implementation of quality analytics in manufacturing, which makes sense, right? The analysis that you get out is only as good as the data that you put in, and that certainly hasn't changed in all the years of analytics. The other interesting time where data as a kind of successful outcome came through this question. So with this question, we put these 10 different kind of KPIs or objectives in front of the respondents and said, rank them first in terms of their importance at the outset of an Industry 4.0 initiative. So when they're considering or scoping, what do they consider? And then second was the exact same list and saying, what has actually seen the greatest success? Where did it exceed expectation or fall short of expectation? And again, what I found interesting was that enable big data analysis was not initially a defined goal. And maybe that's sometimes because it can be hard to quantify that compared to, say, prove out an ROI at the top. But once implemented, people are seeing huge success just by having that visibility of the data. And maybe one of the reasons prove out ROI drops so much is that sometimes the problem, once you can see the data, wasn't actually the problem that you expected, but it does mean that you can now go and attack that. So I find that really interesting to see how the data itself is actually a hugely successful outcome of some of the Industry 4.0 initiatives implemented to date. Mike, coming to you, how do you see that within the successful deployments that you've had, and what insights can you share on that?
Great, thanks, Dave. The example I want to bring up is the company Micron, right? Micron is a semiconductor organization, manufacturer, And, this is a use case, and I love this use case, because it really talks about the scope of data and the importance of data to meeting very important corporate objectives. In the semiconductor world, yield is everything, right? And what's really interesting about the semiconductor world is that, if you look at the cycle time in terms of how long it takes to make a single chip in this industry, it takes oftentimes as much as 6 weeks from when you start manufacturing this chip, going through the etching and masking process to when it actually ends up being a fully packaged memory chip at the end of its manufacturing process. So one of the key objectives here would be, look, if it's taking me 6 weeks to make this chip, and I introduce a defect somewhere along the line, detecting that defect becomes critical, because the last thing you want to do is introduce a defect in week number 1 and continue processing it for 5 more weeks. So we work with Micron to be able to detect defects as quickly as possible. And to do that, we really needed to use a extremely wide range of data. And as you can see, that type of data was everything from this time series data, the measurements of the manufacturing process, right, coming off of sensors, time series, transactional data from the ERP systems, from the MES systems, and increasingly unstructured data. So we introduced image analytics, right? So at the end of each etching process, we took a picture and used computer vision to determine whether or not that etching process at that step was accurate or not. Now, here's the thing, and why I love this as a data story. To do this effectively required over 1 trillion measurements per day, and Micron is adding a petabyte of data just for these processes per year, right? So this is incredibly data intensive. Now, what they did by adding all these different types of data into the analytics, particularly on that image analytics, right, what they could do was they improved their ability to detect defects from things that would take 7 days. So think about this. If there was a defect, they only found out 7 days down the line, to being able to detect those problems in less than an hour. So this is a great example of where process efficiencies are everything. And in the semiconductor world, what's it, yield and being able to detect defects quickly. Underlying all of that is data, and increasingly larger and more diverse types of data. That's why I really like this use case a lot.
Absolutely, and again, tying that to the kind of productivity and reducing costs, for example, later down the line. Joseph, what about from your perspective the data challenge and examples where you see that being solved?
Sure. Of course, I think as mentioned, data is the base of everything. Having the data right is very, very important. And as we work with many clients in manufacturing space, of course, we find very cumbersome environment for data. Data, coming from different applications. There's no a single data model covering a factory, for example, etc. So how can we bring this data, extract the data from different systems without having to necessarily replicate the data, but getting access to the data, convert the data and make this data consumable for a number of applications becomes a very, very important topic. In fact, together with Gartner, IBM believes that the new wave for data management is what they're calling a data fabric. That's pretty much a layer to allow you to do the data governance in a much more, addressing the shortcomings of the data lakes, etc., that happened in the past. But data lake is the way to go forward, and this is pretty much what we have been doing with this client. I believe, no need to introduction, L'Oreal, one of the major, consumer company worldwide for cosmetics, and they have a large number of factories around the globe. pretty much. And L'Oreal, being in the consumer industries, they have to be extremely connected to the market, more or less. Their demand, what we're going to be producing in a given factory, needs to be aligned with the market demand, and they have to reconfigure the factory on the fly as fast as possible in order to move it from, let's say, shampoo type 1 to shampoo type 2 or whatever, right? So we work with L'Oreal, right, and deploy a solution that would allow us to connect with different systems they have in the factories. They have a number of equipments from automation vendors, etc. And we bring this information into what we're calling IBM Plant Service Bus. It's a connection of capabilities to bring this data in, convert the data, and make the data available for a number of applications that we develop for L'Oreal as well, right? For example, in their situation, not only the reconfiguration of the plant is very, very important, so provide applications to allow the operator to do the reconfiguration, but also looking at the capabilities of the machinery, if the machines are going to break down, and look at the quality of the product. For example, in their business, the viscosity of a given material becomes very, very important topic. Again, this was a large-scale implementation across all 43 plants that L'Oreal has around the globe. So that was a good example of how we dealt with a client and bring the data together to enable this whole digital transformation for their industry.
Thank you. And yeah, data fabric is probably my word of the year in terms of popularity across certainly the events and such like is a very hot topic right now. Ricardo, what about the Telit perspective on the data challenge?
Thank you, David. If you can move to the next slide, please. I would like to share this slide from one of the use cases, one of the projects that we deployed in the largest electronic manufacturing company in the world. And I really like a lot the example that Mike also brought from Micron in the semiconductors space. Actually, this one is not in semi per se, but electronic assembly and manufacturing. But the idea is very much aligned with that. If you have problems in the manufacturing line, doesn't matter if you are manufacturing chips or if you're manufacturing cars, or in this case, if you're manufacturing ink cartridges for printers, you need to have the ability of really collecting this data in real time, to analyze this data in real time and provide insights for operators and managers to take the right decision in terms of keeping up the productivity there. In this use case, the biggest challenge that we had was, first of all, being able to collect the data given the ultra high frequency that these machines work. That was the most impressive production line I've ever saw. The machines, they move so fast. And as you know, a POC deletes the tag, the results, the data that it produces every cycle. So you need to be able to collect in the speed that they generate. And some POCs might easily generate 200,000 tags or more. So DeviceWise was the only solution that this company was able to use to collect this data in super low latency in order to provide reliable data there. We use DeviceWise 100% on the edge to do all the calculation between good parts and bad parts, cycle times, actual versus forecast, so all the different inputs, transforming this in KPIs such as OEE, production yield, throughput analysis, and more. We created this complete digital twin for the factory, for every line, where people could drill down on the productivity machine by machine in real time. We created this control room so all the data, historical and real-time data, becomes available for the team. Creating all the alarms, so if something is going wrong, people can go and fix the problem in the very same second that it happens, not days or weeks after that. So, and that is what will really bring productivity with the technology, is the ability of transforming the data that you are collecting in real actions for you to keep improving your productivity and your cycle times. That's a very interesting use case that I would like to share with you.
Thank you, Ricardo. And yeah, again, it's the data having the data there to be able to actually look at it and analyze and understand the problem in the first place, that kind of data availability and visibility is incredibly important. And again, goes back to our setting the foundation that we were talking about at the beginning. So let's finish up by looking at the future applications. If the foundational layer has been laid, what do we expect to then see put on top of that next? And this is actually the same question as we saw earlier, but rather than asking what is currently adopted right now, this was the same question, but which digital technologies do we plan to adopt in the next 24 months? And you can see that actually, it does get a lot more specific. With the foundation in place, people are moving on to the real-world applications. So, in particular, robotic process automation, RPA, additive manufacturing, and even blockchain and machine learning up there as the kind of the next steps in people's Industry 4.0 digital transformation journey. The other question here, which was interesting, was we actually put the Industry 5.0. We're not even done with 4.0, but we move on already. And particularly the kind of the themes of sustainability and well-being, for example. How much of these already being considered within the Industry 4.0 or 5.0 initiatives right now? And actually, the response was pretty high. You know, we've got there, you know, only 17% saying that it's not being considered at all, and kind of 50% plus or saying that it's already at the center of the strategy or being directly considered. I think particularly where that can be tied to a business goal. So, for example, you know, sustainability through energy efficiency to the costs of the business, to the cost of manufacturing. I absolutely see how that can already be considered, but it gives an idea of where things are headed next. So let's talk again back to the kind of the more application layer. Ricardo, for you again, how do you see this coming next? What do you see the next wave of applications being in the next, say, 12 to 24 months for Industry 4.0 or 5.0?
Yeah, David, as I said at the beginning, I think you know, this really shows that the industry is investing. We are no longer talking about only POCs, but we're talking about real deployments. Basically, every company out there is really thinking in terms of how they can improve their productivity by the adoption of the technology. Robotization and automation, digital integration is something that came to stay, and we're going to have a big window of opportunity for end users and for technology providers, probably for the next 4 to 5 years. My personal prediction is that after this period of time, technology will really filter the survivors of this industry, the ones that really can adopt the technology in the best way to be more efficient there in this industry. So my final comment here is, the most important thing is that companies really think in terms of the foundations for these technologies to be successful. Data analytics is incredibly important. Cloud computing is incredibly important. But a good data analytics starts with a good data set. You need to be able to collect the data from your machines in an efficient way. You need to make sure that you transform the mindset of your people in terms of using the data to improve your process. The most automated companies are the ones that will have the highest productivity levels. So this IT-OT integration, this digital integration, and also 5G comes into the picture in the next couple of years. I think this will bring significant transformations that you need to have a very solid foundation for you to succeed on the deployment of these many different components that will be necessary to keep increasing productivity.
And again, always tied back to the productivity and the efficiency, of course, makes sense. Mike, what about your perspective from Cloudera side? Again, what are you expecting to see the most of in the next 12, 24 months?
Great. You know, and what I'm expecting to see is what we're already just starting to see right now. I think Ricardo put it very well. If you look at the slide, you know, if we look at the future, right, which are kind of the top types of use cases around, let's say, robotic process automation. You're only going to get there if you do those bottom ones, the cybersecurity, IoT, cloud foundation that we talked a lot about earlier. what we're seeing is kind of consistent with that. We've seen that companies have started and are largely succeeding in putting in those foundational components. Remember the data management lifecycle, they've put in their data lakes, right? They're starting to bring data sets together. They're providing self-service BI to their end users. There's machine learning experiments have really started, and some people have been very good at getting them to scale. I think that's still a challenge area. But when you see, ML kind of up towards the top there, if you're trying to get to that holy grail of, say, robotic process automation, we're starting to see that, right? So we start to see those machine learning models not only consuming data to build those models, right? But we're using the machine learning models themselves to control outputs, right? And so you need integration of those machine learning models to your PLC systems in the plant. And that's how you get to true equipment automation, that you see that robotic process automation. And we've worked with several customers now that have taken those machine learning models and have those machine learning models, when they're running, actually controlling the inputs to the machines on the assembly line. So you're starting to really see that holy grail of that fully automated plant and smart equipment come to being. And so I predict, that we're just going to see more and more of that. I think we're still in very early days, but I think the future is going to be very exciting.
It's evolution rather than revolution still, I guess, for these companies.
I think that's right.
And Jose, coming to you, I think with a couple of the more futuristic and cooler applications that you're already seeing as well.
Yeah, I think all good comments made by our colleagues here, but I want to focus on the two topics on the top of the response here. One is, again, automating processes, right? And this is bringing the automation to the next level, automation of the processes that have a lot of knowledge behind it. And how can we use AI in the process of making this business process automation, bringing this business process automation to the next level. But the case I wanted to share here is about, how we bring now leverage on the new developments around robots, how we bring robots to help us perform the tasks that we have in a factory that could be dangerous to a human, for example, right? We are working in this case with Boston Dynamics. I believe you may know Boston Dynamics, a major manufacturer of robots. And we are pretty much having now, as you see here in the picture, a kind of a moving robot that is completely autonomous. You give the robot a task to go out and inspect the factory over a number of topics, and the robot go there and they start looking at with capabilities, of course, in terms of infrared capabilities, vision, etc., to start looking at some specific process, identifying cases that need to be fixed. And as the robot goes through his inspection in the factory, it is of course integrated with a system like a Maximo, and can create work orders for someone to go after and fix that specific situation afterwards. That's one example of how do we see the automation being brought to the next level. And of course, another angle of automation is the automation of the IT, how we can make sure that you can automate or optimize the computing resources to execute a given task. That's another angle of automation that's usually something that's coming up more and more as we go forward. Okay, so that's one. The second one, if you go to the next case, this is another one around the 3D printing. This is a work we did with Ricoh. As you may know, Ricoh is one of the largest office equipment suppliers in the world. And in this case here, we are working with Ricoh in bringing IBM capabilities in their capabilities to help on the medical doctors to perform a surgery in a much more efficient way. So as the doctor is planning for the surgery, for example, a heart surgery, would be very, very important for them to have the heart model of that specific patient that's going to go through the surgery, for them to train and design exactly the best way to perform the procedure. So we can expedite the 3D printing of the organs to allow the doctors to perform their job much better way as well. So that's another very cool case. It's feature, but again, it's feature being brought to present to allow us to do things that were not possible to do before.
And that's the digital transformation with the focus on transformation right there at the end. Unfortunately, we're pretty much out of time. So I want to thank all of our panelists. So Jose, Ricardo, Mike, thank you for all of your time. Thank you to our audience for joining, and do take a look at the resource list against this webinar. You should be able to find the link to the report, so you can dive into some of the detail and a few of the other questions that we didn't have time to share today. But yeah, thank you for everybody's time. Thank you for joining, and I hope to catch you again soon on one of these webinars or one of our live events.